Hello everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So today in this session, we will discuss about the method of variation of parameters. So what's the method of variation of parameters? So for what type of the differential equations we are going to use the method of variation of parameters, and we'll see the problems on this. So first we will see the working rule on method of variation of parameters, and we will see the problem on the method of variation of parameters. So now we will see the working rule. So the working rule is, see the step 1. The step 1 is for what type of the differential equations. So we are going to use the method of variation of parameters. So the differential equations of the type, the second order differential equations with the constant coefficients. So what is the second order differential equations? That is d square y by dx square plus p into dy by dx plus q into y is equal to f of x. So here p and q are constants. So for this type of the differential equations, so we are going to use the variation of parameters to find a general solution. So see the step 1 to find out. The step 1 is finding the complementary function. So already we know that how can we find the complementary function. So to find the complementary function, so after getting that, you have to assume that complementary function as c1 y1 plus c2 into y2. The next is step 2. So what's the step 2 to find? So you have to calculate the Wronskian. So what's the Wronskian mean? The determinant of y1, y2, y1 dash, y2 dash. So here, what's the y1 and y2? So this y1 and y2 we are taking from the complementary function. So what is nothing but y1 dash and y2 dash? Y1 dash and y2 dash is nothing but the derivatives of y1 and y2, and these y1 and y2 are taken from the complementary function. So and this w is nothing but the Wronskian of y1 and y2. Wronskian of the y1 and y2. And next we have to find out the particular integral. So what is the particular integral? The particular integral is defines u1 into y1 plus u2 into y2. So then how can we find the u1 and u2? The u1 is defines integral minus integral y2 into f of x. So what is the y2? So y2, this y2 function we are taking from the complementary function, and the next is the f of x. So what is f of x? So from where we are taking this f of x? From the given differential equation. So divide it by w. So w is nothing but the Wronskian. So what's the Wronskian defines determinant of y1 dash, y2 dash, y1, y2, y1 dash and y2 dash. So then now we will see the next to find the u2. Then how can we find the u2? u2 is defines integration of y1 into f of x divided by w into dx. So this is the way to find the u1 and u2. So after finding this u1 and u2, we have to write the particular integral. So that particular integral is u1 into y1 plus u2 into y2. So then now we have to write the finally the general solution is the last step. So this is the last step. The complete solution, it's given the complementary function plus particular integral. So already we have the previous method to find the general solution of the second order differential equations, but here we are using the other process to find the general solution of the given linear differential equations. So what is that method we are using here? The method of variation of parameters. So in the method of variation of parameters, so first we have to check whether the given differential equation is of order second order. So that is d square y by dx square plus p into dy by dx plus q into y is equal to f of x. So this is the second order. So for this second order differential equation, so first you have to find the complementary function. So that complementary function is nothing but yc is equal to c1 into y1 plus c2 into y2. Right? So here y1 and y2 are the linearly independent solutions. So after finding the complementary functions, you have to find the particular integral. So what's the particular integral? So particular integral is defines yp is equal to u1 into y1 plus u2 into y2. So this defines the particular integral. So what is u1 and u2? u1 is equal to minus integral y2 into f of x divided by w into d of x. So we know that what is w is nothing but the Wronskian. Then now the u2. So u2 is defines the integral y1 into f of x divided by w into dx. So these are the two formulas by finding the u1 and u2. So here the w is nothing but the determinant of y1, y2, y1 dash and y2 dash. So then how can we find this determinant? So we know that what is the determinant of A, B and CD? So that value is AD minus BC. So likewise y1 into y2 dash minus y1 dash into y2. So this is the Wronskian. So Wronskian is nothing but y1 into y2 dash minus y1 dash into y2. So this is the Wronskian. After finding this w, u1 and u2 values, you have to directly substitute in the particular integral value. So that particular integral yp is equal to u1 y1 plus u2 y2. So after getting this particular integral, then finally we have to write a general solution. So that general solution or the complete solution is it's given by y is equal to yc plus yp. So yc plus yp. So this is the working rule to find a general solution for second order differential equations with constant coefficients by using the method of variation of parameters. And now we'll see the problem on this method. So now see the question. To solve d square y by dx square plus y is equal to cosecant x. So d square y by dx square plus y is equal to cosecant x. So by using method of variation of parameters. So using the method of variation of parameters, and now we are going to solve this type of the differential equations, right? So now let's see the solution. So first we have to find a complementary functions. So before writing the complementary function, so you have to check whether the given differential equation is a second order or not. So clearly the given differential equation is a second order. So now we can use the method of variation of parameters. So first to find the complementary function. The complementary function we are denoting it as a yc. So to write the complementary function we have to write the auxiliary equation. So the auxiliary equation is nothing but the algebraic equation of f of d into y is equal to 0. So the algebraic equation of f of d into y is equal to 0. So what is f of d? From the given differential equations, you have to write the f of d. F of d is nothing but d square plus 1 into y is equal to 0. So here f of d is nothing but d square plus 1. To find the complementary function, the algebraic equation of f of d. So here the algebraic equation of f of d is d square plus 1 is f of m is equal to 0 is the algebraic equation of f of d into y is equal to 0. So f of m is nothing but m square plus 1 is equal to 0. How did we get this m square plus 1? Already we have f of d. So f of d is nothing but d square plus 1. In this place we have to substitute d by m. So that is the algebraic equation. So now we have to get the roots. So what's the roots of this differential equation? M square is equal to minus 1. So m square is equal to minus 1, so that m is equal to plus or minus I. So here plus or minus I is a complementary function. Plus or minus I is a complex roots. For this complex roots, how can we write the complementary function? So what's the form of a complex roots? Alpha plus or minus I beta. So what's the complementary function to write of this type of the roots are? Yc is equal to e power alpha x into c1 cos beta x plus c2 sin beta x. Right? So likewise, we have to write the complementary function on this roots. So that Yc is equal to, so here alpha is equal to 0. So clearly you just compare with this. So alpha is equal to 0 and beta is equal to 1. So e power 0x into c1 cos beta is nothing but 1 into x is x plus c2 sin x. c2 sin x. So this is the, again e power 0x is nothing but how much is 1. So that e power 0x is 1, yc is equal to c1 into cos x plus c2 into sin x. And now again we are going to assume this as c1 into y1 plus c2 into y2. So what is the y1 here? Cos x. Y2 is nothing but sin x. Right? So here y1 is equal to cos x and y2 is equal to sin x. So now we have to find a particular integral. So before going to find the particular integral, so now we will find out what's the Wronskian of y1 and y2. So Wronskian of y1, y2 is nothing but determinant of y1, y2, y1 dash and y2 dash. So here y1 is cos x, y2 is sin x. So y1 dash is nothing but derivative of cos x. So derivative of cos x is minus sin x. And next is y2 dash. Y2 dash is nothing but the derivative of sin x. Derivative of sin x is cos x. And now apply the 2 by 2 determinant here. So that 2 by 2 determinant is the cos square x minus of minus sin square x. Right? So cos square x minus of minus is nothing but plus. So cos square x plus sin square x. So clearly the cos square x plus sin square x value is 1. So here the Wronskian of y1 and y2 value is 1. Right? So now to find the yp. So now to find the yp, so let us consider the yp is equal to u1 into y1 plus u2 into y2. So here u1 is equal to minus integral y2 into capital F of x divided by w into dx. So here the minus y2 is nothing but sin x. So what is f of x? Cosecant x. So sin x into cosecant x into dx. And now you have to integrate on this function. So this is equal to minus integral sin x into cosecant x can also be written as cosecant x is nothing but 1 by sin x. Into dx. So here the sin x and the sin x is gets cancelled, minus integral 1 into dx. So integral 1 into dx is nothing but x. So before we have the minus, so take it as the minus x. So this is the value of u1. And now we'll see the u2 value. So what is u2 defines? u2 is equal to integral y1 into f of x divided by w into dx. So y1 is nothing but what? y1 is cos x. What is f of x? F of x is cosecant x. Vronsky value is 1 divided by 1 into dx. So this is equal to integral cos x into cosecant x. So cosecant x is nothing but 1 by sin x into dx. So cos by sin is cot x. So integration cot x dx. So what's the integration of cot x? Integration of cot x is log mod sin x. So integration of cot x is log mod sin x, and this is the value of a u2. And now we have to write the particular integral. So yp is equal to u1 into u1 y1 plus u2 y2. So what is the u1? u1 value is minus x. What is the y1? y1 is cos x plus what is the u2? u2 value is log mod sin x. Then now the value of y2 is sin x. So and this is the value of the yp. And now we have to write the finally complete solution or the general solution. Now the complete solution is y is equal to yc plus yp. So here the complementary function is c1 cos x plus c2 sin x plus yp. Now the value of the yp is minus x into cos x plus sin x into log mod sin x. So this is the complete solution of the given differential equation by using the method of a variation of parameters. Right. So what's the topic we discussed today's session is, so using the variation of parameters, we solve the second order differential equation with the constant coefficients. So what's the working rule? The working rule is first you have to find the complementary function. So that complementary function you have to assume it as the yc is c1 into y1 plus c2 into y2. Right. And now next we have to assume the yp. The yp is u1 into y1 plus u2 into y2. So now you have to find this yp by taking the formulas of u1 and u2 and the Vronsky value we have to find out. So after finding all those values, you have to substitute in the yp, and finally we have to write the complete solution. So that complete solution is nothing but y is equal to yc plus yp. This is the complete solution of the given differential equations. That differential equations of the type is the second order differential equations with constant coefficients by using the method of variation of parameters. Right. That's all for today's session. Thank you.